Good morning, everybody. My name is Nele Katour. On behalf of EUPPA, the European Potato Processors Association, Mr. Bill Bartlett will give a presentation on acrylamide reduction in French fries. There is time for question and answers after the presentation. Please feel free to send your questions using the interface. They will be anonymous.
Thank you, Nele, and good morning. Today we're going to take you through the important subject of acrylamide reduction in French fries. The webinar is structured in sections to focus in on the key areas relating to acrylamide reduction. We will start by taking a look at the background on acrylamide in food, then get an understanding of risk management issues within the context of the EU. I'll take you through a short explanation of the management concept ALARA, which is as low as reasonably achievable, and then we will focus on the food industry toolbox, which features tools that help industry manage acrylamide reduction. Then we'll drill down on the French fry toolbox and take a quick look at the technical details of mitigation tools. Finally, I will summarise, and myself and Nele will take questions at the end. So what is acrylamide? Firstly, it's an organic chemical compound which is used in a variety of industrial applications, including the production of plastics, the preparation of polyacrylamide gels used in laboratories, water treatment, soil treatment and cosmetics. It's a known neurotoxin which can disrupt the nervous system and a genotoxic carcinogen. There are some maximum levels for acrylamide in relation to its presence in food and water that exist as indicators of improper use. These levels, however, are not safety levels. Examples of these levels are ones that limit the migration from materials in contact with foods. The absence of detection limit here is 10 micrograms per kilogram. In drinking water, the levels are set at a maximum 0.1 micrograms per litre. This is in place where acrylamide is used in water treatment. For clarity though, I will restate that these are not safety levels. In relation to the history and context of acrylamide in food, acrylamide was only discovered in 2002. Researchers in Sweden were looking into the implications of acrylamide in occupational exposure and discovered acrylamide present in a wide range of common food items like potato products, bread, biscuits and cereals and in coffee. This was unexpected and new knowledge and potentially had an effect on common cooked foods worldwide. Many cooked foods subsequently were found to contain acrylamide at levels of parts per billion, and extremes may be in excess of 5,000 parts per billion. So how is acrylamide formed? It forms naturally in starchy foods as a result of heating at high temperature, temperatures above 120 degrees C. It is present both in commercial and domestic, traditional and modern cooking processes, and it is formed when the Maillard or browning reaction during cooking, which has been confirmed as the major formation route for acrylamide. This is where reducing sugars, amino acids and high heat are present. The results is evident in the colours and the flavours portrayed, and specifically when fructose, glucose, asparagine and high heat are present. This results in acrylamide formation of varying levels in many common food groups. The amount of acrylamide formed depends on the available levels of asparagine and reducing sugars, the temperature and cooking time, as well as the ultimate finished product moisture. To summarise, these are the critical stages of acrylamide formation in common food production. And as you can see, in the area of French fries, they are sugar in the agronomy stage, processing temperatures, and final colour preparation. I'll cover these more later. So that's a little on the background of acrylamide. Now let's take a look at the risk management issue. The European Commission are stating that there are now sufficient grounds for precautionary measures to be adopted in relation to acrylamide formation. Risk assessments indicate there is human health concern for acrylamide in food, and risk assessments carried out by global experts working for the WHO and the Food and Agriculture Organization in 2005 and 2010 indicate acrylamide as a human health concern, and efforts should be made to reduce exposure. In particular, there is one important piece of research which was carried out in the USA, which was the FDA National Toxicology Program report in 2011. This confirms tumour formation in animals, but implications for human health is still unclear. There is also an EU risk management review now underway, and the decision regarding whatever measure the authority feels are suitable and relevant is expected by the end of 2012. So it's an active regulatory risk management issue now, and in the European Union there are some recommendations in the regulation that extend the monitoring of acrylamide in the market by member states in a range of food categories. These recommendations require monitoring indefinitely to gather information about the levels found in common foods and how those levels have been affected by industry actions. The European Commission have recommended indicative values to guide member states in reviewing the effectiveness of acrylamide mitigation tools that would reduce or prevent the formation of acrylamide during cooking. The aim is to get a better overview of the reasons for acrylamide levels in some foodstuffs that are significantly higher than the levels in comparable products in the same product category. And the investigation can be triggered where levels are found above indicative values. These are not safety levels and have been set at the 90th percentile of levels of the EFSA 2007 to 2008 monitoring database. And the indicative value for French fries is 600 parts per billion. Regulatory investigations and challenges are now occurring in many countries throughout the EU, requiring evidence from food business operators, caterers and manufacturers that acrylamide reduction measures are in place. And what about active regulatory risk management in the rest of the world? Well, Codex Alimentaire have already and quite rapidly developed a code of practice for reduction of acrylamide in food based upon the 2005 Risk Assessment Survey. They plan to revisit acrylamide risk management after allowing time for the code of practice to be taken up by industry and food processors. Outside of the EU, in other countries, in the US, the FDA in-market monitoring got underway in 2011, with guidance planned to be issued very soon. And the new Food Safety Modernisation Act, which includes hazard analysis plans for contaminants, now includes acrylamide. In Asia Pacific, countries are focused on implementing the Code of Conduct practice as they are in Latin America. So, let's now talk a little more about the concept of ALARA as low as reasonably achievable. Why is ALARA so relevant to acrylamide? The risk management concept of ALARA simply means that a food business operator should take appropriate measures to reduce the presence of acrylamide in the final product to a minimum. And the efforts to achieving ALARA management should take into account of the feasibility and effectiveness of proposed controls, the potential risks from other contaminants being generated by new or changed condition. For example, a risk assessment would need to take place in the case of reduced microbial controls as a result of lower thermal input or cooking and temperatures. Also, when conditions are changed, the organoleptic properties and quality of the final product need to be understood so that taste and consumer preference is maintained. So the other point to make is that ALARA is an ongoing process, which means you will need to ensure continuing compliance with ALARA risk management, which in turn means monitoring the effectiveness of the implemented measures you make, and an ongoing review process needs to be in place. So taking into account that the EU authorities are saying that there is a need for food business operators to take precautionary measures, there is an expectation across member states that mitigation levels should be applied to ALARA levels. Risk assessors are therefore recommending a recommendation of acrylamide exposure in the diet, and risk managers are therefore now expected to offer evidence that levels as low as reasonably achievable are demonstrated for acrylamide in food, and be able to demonstrate that the toolbox that has been developed by the industry is being used and they are applying mitigation tools effectively throughout their operations. And to note, if there is a process that proves to be inefficient within your operation for acrylamide reduction, then it is important that you can demonstrate you have tried to apply it and justify the ongoing lack of adoption. In the market, it is now also expected to show the ongoing impact of acrylamide mitigation. Also, this is likely to drive increased challenges and sampling visits to operator sites. This slide is designed as an example of what effective ALARA mitigation efforts to minimising consumer exposure can look like. So if you look at the bar on the left-hand side of this chart, you will see an example of the acrylamide range found in a production batch before mitigation. The blue box being the median, and the red and the green dots being the respective max and min levels. Moving to the right, if you optimise your design profile, you can see you are reducing the range of exposure to the maximum levels, even though the median remains broadly unchanged. Moving further right, if you modify your design profile, you can get a lower average exposure, even though you may still get occasional higher levels. And finally, if you created a new design profile with more radical mitigation, you can significantly reduce exposure. Presenting your mitigation efforts in this way can be very useful in demonstrating ALARA principles have been adopted when external inquiries are made. So let's talk now about the food industry toolbox. As an industry, we shared knowledge across the whole food industry to create this toolbox, particularly sectors who have similar technologies and who use similar ingredients. This enabled a lot of insights and technical understanding to become very helpful across all of the sectors. So here are the groups who have been mainly responsible for putting the toolbox together. The food industry toolbox aim is to clarify and identify the status of potential acrylamide mitigation tools in a range of food categories, and there is the link that you can go to look at the latest version of the toolbox, which has been kindly endorsed by the European Commission on their website. It was first published in 2005, revised in 2008, and the latest revision was published in September 2011. This is an organic and live document which is regularly reviewed and updated by the Toolbox expert team. It provides potential design tools which may mitigate acrylamide formation when applied as part of the optimum product design, whilst maintaining key product characteristics. We say may as the tools may not work for all operators. When this is the case, as I already mentioned, the operator in question needs to be able to demonstrate that they have tried the tool and justify why it did not work. And the toolbox forms the basis of a lot of the content for the Codex Code of Practice for the reduction of acrylamide tools. The toolbox is arranged in sections and is designed to be a reference guide to the different mitigation tools and how they can be applied. It gives comments and examples to give you as much context as possible, and as you can see, these sections address the different stages of the product life cycle, from agronomy, where the focus is on sugar levels and asparagine levels, through to consumer guidance and the final preparation process. Each tool is classified according to its stage and status of development, whether it be at laboratory, pilot, or on an industrial scale. This gives an indication to its proven effectiveness or its future potential. So drilling down onto the French fry toolbox. Here are the French fry mitigation options, starting with the raw materials. Only use low sugar potato varieties suitable for fried potato products. Store potatoes in climate control conditions above 6 degrees and check temperature and humidity. Suppress sprouting in stored potatoes using CIPC or equivalent agents. Check incoming potato lots through fry colour testing and other tools to measure reducing sugars and remove immature tubers. Moving on to design, cut thicker French fries. Thicker French fries contain less acrylamide through the surface area volume effect. And looking at the design process, blanching potato strips in water is the most important tool to control reducing sugar levels before frying. The addition of a disodium diphosphate directly after blanching can reduce acrylamide levels in the final product through the pH effect. And finally, the final preparation. This is the area that is beyond the processor's control. This is the area where the domestic consumer or the caterer cooks the product. But it's our responsibility to give clear cooking instructions on pack, which are to fry at 175 degrees C, not to overcook, and to aim for a light golden colour, and advice on when cooking smaller batches. And finally, a final colour check against the product specification after frying should be according to the cooking instructions. So to look at the technical details of these mitigation tools, We'll start with raw materials. As already mentioned, the key area here is to manage reducing sugar levels in the raw material, which is an area that our industry has been focused on for many years, way before the 2002 acrylamide research was published. It starts with agronomics, and reducing sugars can be managed in areas such as fertility impact on acrylamide, variety screening, development and optimization, and the introduction of sugar-stable varieties to reduce variable sugar levels. In the areas of harvest techniques and storage conditions, specific focus and management of optimized time of harvesting, chemical maturity, variety-specific storage optimization, which I will touch on in a moment, defect and bruise management, storage ventilation and temperature management, storage facility survey, and crop storage monitoring, which is routine monitoring to gauge the levels throughout the storage period. And finally in this area, transport and plant handling. Transport optimization, testing from farm to plant, and the inventory optimization, the best practice management of stores and varieties to reduce sugar in the finished product. Here we have the recommendations for good storage practice to manage reducing sugar levels in potatoes. Firstly, avoid using potatoes stored below 6 degrees C. Transport from farm to factory at a temperature above 6 degrees C for long storage. The use of sprout suppressants following good agricultural practice, and extending reconditioning at a higher temperature, for example to ambient, over a period of a few weeks. Let's take a look at potato supply management and why it's so important. As we know, there is no single potato variety that can provide all year-round supply, but managed correctly, sugar level variations can be minimised. For example, potatoes harvested in September and October should be tested for risk batches of potatoes where it is identified that sugar levels will rise during storage, and these should be processed as soon as possible. Also, regular testing in store throughout the storage season can also identify risk batches, and these can be produced and these can be processed before the levels get too high. You should select low sugar varieties where possible and develop new varieties with low reducing sugars. But as we know, this is not a short-term fix, as the breeding program, once a variety has been identified, and this in itself can take years, from that point is 15 years. Apart from new varieties, there is some evidence to suggest that higher nitrogen levels leads to higher sugar content, which is probably linked to a more maturity effect. And moving on to entrance control. Regular checks of the levels of sugar of inbound potatoes should take place during a USDA-approved colour test or the Agron colour measurement device to ensure reducing sugar levels are as low as possible. This should take place after the sample of the inbound potato load is fried, and it should form a key indicator of the acceptability of the load. From a processing perspective, the impact of temperature and frying time is critical. Par frying itself doesn't produce significant levels of acrylamide in semi-finished product, nor does it determine the level in the finished product. Reducing frying temperature can have unintended consequences and can result in increased absorption of fat during the finished product process. Low moisture content equals higher acrylamide formation, therefore the end phase of the frying process is critical and must be carefully controlled. However, it's a fine balance as incomplete cooking affects moisture levels and subsequently product quality life and microbacterial, I can't say it, damage. Pre-treatments, whilst it's desirable to have thicker fries, it's not always possible due to consumer preferences. And as far as blanching is concerned, this is an important tool to reduce the reducing sugars in the blanching process, is disodium diphosphate, which is added to the blanching water in the par-fried, frozen, French fry process to prevent grey discoloration of uncooked potato strips. It also has a significant secondary effect in lowering pH, which in turn lowers acrylamide levels. Blanching must be managed to final product colour specification of the client and should be routinely monitored by the use of the Agtron machine or the USDA colour testing process, and should form part of the QA protocol. What you can see here is a range of Agtron colours and the direct correlation to acrylamide levels. This clearly highlights the importance of inline colour monitoring of the product and how important it is to narrow the variable ranges by adoption of mitigation processes. And moving on to final preparation. Cooking instructions for consumers who are frying or oven baking, and indeed caterers, must offer clarity to how to achieve the best product for consumption at the lowest possible acrylamide levels. Fry time needs to be clear, and as does the cooking temperature at 175 degrees C. Not only is this important for the issue of acrylamide, but fry time and temperature also have a direct impact on fat absorption. However, in the final preparation there are some bottlenecks. There is a consumer preference for golden brown French fries in some European countries, and we as an industry cannot simply change local consumers' preferences to lighter colour. We have to work with the restaurants and the consumers and educate them. This is where our role comes to play. And the industry continues to offer clear advice and assistance to the end preparer to achieve this. And finally, what has the industry done? Firstly, it's applied the tools as indicated in the FDE Toolbox revision number 13 published on the 1st of October 2011. The industry provided much input from for the March 2009 meeting Codex Code of Practice for acrylamide reduction in potato products. Pamphlets have been developed by sector to enable a broad knowledge transfer of best practice for small and medium enterprises. These were updated in February 2009 and again in June 2012. Questionnaires were sent to European fry producers in 2006, 2008, 2010 to verify awareness and implementation of the tools. EUPPA initiated independent research with Kent University to further investigate acrylamide mitigation tools in lab trials and to verify the opportunity of these at an industrial scale. And finally, there is ongoing instructive meetings with the European Commission to progress mitigation solutions. So I'd like to thank you for your time, and now myself and Neil will take any questions.
Thank you, Bill. In case we don't have time to take all questions, we will send you a reply by email. A first question, Bill. Somebody is interested where they can find the results of the, where they can find the toolbox.
Yes, if you go onto the European Commission site on the link that we've got on page 19, on page 19 you should be able to follow that through and find the toolbox.
Yes, just for your information, the presentation will be available for everybody, so you can just click on the link to the website of the European Commission.
Yeah.
Then next question, you've talked on the EUPPA questionnaire in 2006, 2008 and 2010. Are the results available for this questionnaire?
Yes, they are.
Okay, we can maybe find out who asked that question and send the answers to them. Another question. Somebody asked, you've talked a lot on what industry has already done, but how can we further educate our customers in good frying practices, as most end users are constantly defining by themselves how to best fry their fries and do not listen to us as supplier?
It's a very good question, because that is the area that is most critical for acrylamide formation, and EUPPA are working on a website where which I think will be ready in around September time, where best fry practice will be available for consumers and for caterers, and it will be backed up by a supporting video that demonstrates, obviously visually, how a caterer can take positive actions to reduce and mitigate acrylamide formation in the end consumer product.
Okay, thank you. Another question, does the sector have monitoring data and has this been shared with the Commission?
Well, we are monitored by the local regulators. In the UK we are certain, well, the industry, not specifically just our category, the whole industry is surveyed in the spring of every year and publish the results later in that year, and that will continue throughout 2012 and 2013, and that is the same but different time periods across many of the member states.
Yes, I can maybe also add that the EUPPA, so European Potato Processors Association, has its own database as well. We do an internal survey of the data, and we share that data with the Commission, but not in numbers, but we share the graphs to show how it's evolving, the numbers, which is much more important than just a number by itself. Then another question, does changing the kind of oil affect the presence of acrylamide?
I'm not entirely sure that it does. We've seen no evidence of that in any of the tests that we've done.
No. Then another question, does a bruised potato lead to a higher acrylamide level in the final product?
Yes, bruising management is critical, and it's part of the process to actually to reduce acrylamide, and it is actually featured in the toolbox.
Okay. How do we know whether all European potato processors really use acrylamide toolbox? Maybe I can take this question. Of course, we do not know if they all use it. They should. We have, of course, done the survey in 2006, 2008, and 2010, which indicates that a very high percentage, I don't know by heart, but it was almost 100%, does it. There are, however, some smaller potato processors, because for the industry, a company who just, for the Commission, I mean, a company who just peels potatoes and makes fries for the local fish and chip stores. They are also processors, and they are a little bit harder to reach. They are not in our, not all of them are in our questionnaire, but all the major players, they do use it and have used it for a couple of years already.
Yeah, and the presence of the French fry toolbox will be made, these smaller SMEs will be made aware of that by enforcement officers if they are tested for the indicative values.
Yes, that's the whole idea behind it. Okay. Then actually related to that question, what would happen if the indicative level is crossed, or above the 600 ppm for French fries? What happens then?
Well, the guidance values are effectively first checked at the point of consumption, and if it were to be a caterer, the officer enforcing, but following the guidance values, would go through a checklist with the catering operator to ensure that they had applied all possible mitigation techniques. If indeed they had, and it was then seen to be not the operator's issue, they would then approach the food processor to follow a checklist to make sure that the mitigation processes were being adopted within the processing facility.
Okay, thank you. Then another type of question, we've heard about GM potatoes. For example, varieties with lower asparaginase levels being developed in the US. Are you aware of how effective these varieties are in terms of reducing levels in final products? We are aware of these tests. They are still ongoing, and the tests are being paid by private companies, so they don't share the results that much with European processors. So unfortunately, we are not so aware of these results, but we're hoping that they are good. But as you are aware, in Europe we are not allowed to use GM potatoes. So for the moment we're just looking what these tests are doing and try to monitor it. But yeah, due to politics, it's not feasible in Europe to do the same. Then what is this there? most of the measures you show are good manufacturing practices to ensure good quality finished products. Are there specific measures which are additionally needed for acrylamide mitigation?
I think it's safe to say that the industry is a responsible industry, and we have been doing many of these things for many years, even before 2002. I think that it is it's a management and monitoring process that is required, and that's what the toolbox pulls together. It pulls together best practice in a way that can be managed and monitored and reviewed to ensure continuous improvement.
Yeah. Another question on the toolbox. You've said that it is a live document. Do you know how often it will be updated?
It's updated periodically. It will depend on technical developments, best practice that comes in that would suggest that adaptations should be made. So it's not done every month. It's done as and when there are some significant milestones to record.
Okay. A more difficult question maybe. Talking about ALARA, how low would be low enough, and who is deciding what is low enough?
That's a good question. Guidance for French fries is 600 parts per billion, so that it is seen by the Commission, and the local regulatory authorities that less than 600 is desirable. As we've said, there is no probing link for human issues with acrylamide, but below 600 is seen to be a desirable target. We know from testing products across our food category, we can record levels significantly lower than that. So we are acting as a responsible industry, and we are demonstrating that we are coming in below, and in some cases significantly below, the guidance values.
Okay, thank you for that. And I have one final question. It's not really related to potatoes, but maybe we can share our insights. Somebody is interested in cocoa-based products. Do we have an insight on high level, if there are acrylamide levels in these products and how they are?
I haven't a clue.
No, I would refer this person to CAO-BISCO, which is the European Federation for Biscuits, Chocolate Products, and these products. So unfortunately, our knowledge is limited to potato and potato products, but I think there was a webinar on these products before. So maybe it's still available on the FDF website.
We can clarify that, and if it is available, we can send out a link.
Yes.
To the person that asked the question.
Or bring you in contact with CAO-BISCO.
Okay. Okay, I think that's the end of the webinar. Before you go, there is going to be a very brief poll, which you'll see appear on your screen. If you could just take a moment to complete the question. It's very simple, yes or no. Thank you again for your time. Enjoy the rest of the day, and everybody have a nice weekend.
Thank you.
Thank you.